day to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics chapter Lagrangian Dynamics, in which I will give the details concept of generalized component of momentum and generalized component of impulse. Now I will give you the concept of generalized component of momentum. Let q1, q2, q3 Qn be generalized coordinates of a dynamical system. Let r mu vector be the position vector of a typical particle of mass mu at any time t, so that r mu vector is a known function of q1, q2, q3 Qn and t. Therefore, r mu position vector is the function of q1, q2 Qn t. Let delta r mu be the virtual displacement of the particle of mass mu, then delta r mu vector equal to, firstly we differentiate r mu vector with respect to q1 partial derivative of r mu vector with respect to q1 delta q1 plus, now differentiate r mu vector partially with respect to q2 partial derivative of r mu with respect to q2 delta q2 plus partial derivative of r mu vector with respect to Qn. We do not take t because it is the virtual displacement, and in this case delta t equal to 0. Since for virtual displacement delta t equal to 0, we may write this in sigma form, sigma I equal to 1 to n, here q1 1 1 2 2 n. So we may write this partial derivative of r mu vector with respect to qi delta qi. Let this is number 1, this is number 2. Total sum of virtual moments of the momentum of the dynamical system is sigma mu m mu r mu dot delta r mu. Here m mu be the mass and r mu dot be the velocity. Mass multiply velocity is the momentum, and here dot delta r mu means this is moment of momentum of muth particle, and here sigma means total sum of moments of momentum of the dynamical system. This equal to sigma mu m mu r mu dot here value of delta r mu is sigma I equal to 1 to n partial derivative of r mu with respect to qi delta qi. We may write this sigma outside I equal to 1 to n A mu R mu dot partial derivative of R mu with respect to Qi delta Qi. Here sigma this mu. This is number 3. Here we see that delta Qi be the generalized displacement and the whole quantity is virtual moments of the momentum. So momentum multiply displacement is the moment of momentum. So this quantity is called the component of momentum. This part is momentum and the whole is moment of momentum. So this part is momentum. So this part is called the component of momentum and is denoted by Pi. Let this is number 4. Let T be the kinetic energy of the dynamical system. Then T equal to sigma mu half A mu R mu dot square, half mass into velocity square, implies that partial derivative of T with respect to Qi dot, this equal to sigma mu half A mu to R mu dot partial derivative of R mu dot with respect to Qi dot, and this equal to 2 cancel sigma mu A mu R mu dot partial derivative of R mu dot with respect to Qi dot. Let this is number 4. Since R mu vector, position vector of muth particle, is the function of Q1, Q2 dot 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 Qn and T, implies that dr mu by dt equal to partial derivative of R mu vector with respect to Q1 dQ1 by dt plus partial derivative of R mu vector with respect to Q2 dQ2 by dt plus dot 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 plus partial derivative of R mu vector with respect to Qn dQn by dt plus partial derivative of R mu vector with respect to T dt by dt, implies that this is R mu dot. Since derivative with respect to T is written as dot of that quantity, this equal to here we write Q1 dot, similarly here Q2 dot plus dot 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 partial derivative of R mu vector with respect to Qi dot plus dot 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 plus partial derivative of R mu vector with respect to Qn dot plus partial derivative of r mu vector with respect to t dt by dt is 1. This is number 5. This is number 6. Differentiating both sides of 6 with respect to qi dot, we get partial derivative of r mu dot vector by qi dot. Here we see q1 dot, here q2 dot, here qi dot. So partial derivative of qi dot with respect to qi dot is 1, here 0, here 0, so here 1, so remains this quantity, partial derivative of r mu vector with respect to qi. Using 6 in 5, we get partial derivative of t with respect to qi dot equal to sigma mu a mu r mu dot, and this is partial derivative of r mu with respect to qi. This is number 7. Since right side of 4 and 7 are equal, therefore left side will be equal. So pi equal to partial derivative of t with respect to qi dot I 1 2 dot 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 n. Therefore partial derivative of t with respect to q1 dot, partial derivative of t with respect to q2 dot, comma dot 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 dot, partial derivative of t with respect to qn dot are generalized component of momentum. Thus a generalized component of momentum is obtained by differentiating partially the kinetic energy of the system with respect to corresponding generalized velocity. Here we see that qi dot be the generalized component of velocity and pi be the momentum. It has been obtained by differentiating T kinetic energy of the system with respect to corresponding generalized velocity. qi dot is the generalized velocity, ith component of generalized velocity. Now I will describe the generalized component of impulse. Name of the impulse is external force. Let q1, q2 dot 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 qn be n generalized coordinates of a dynamical system. Let r mu be the position vector of a typical particle of mass m mu at any time t, so that r mu position vector is a known function of generalized coordinates q1, q2, q3 dot 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 qn and time t. Therefore r mu be the function of q1, q2, dot 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 qn and t. This is number 1. Let delta r mu be the virtual displacement of the particle of the mass a mu. Then delta r mu equal to, firstly we differentiate r mu vector with respect to q1 partially, then delta q1, then we differentiate r mu vector with respect to q2 partially, then delta q2 plus dot 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 plus we differentiate r mu vector with respect to qn delta qn. We do not include partial derivative of r mu with respect to t and multiply delta t, because this is the virtual displacement, and in the case of virtual displacement delta t equal to 0, so that term will be 0. We may write this as sigma form, because here 1 1, here 2 2, here n n. So we write sigma I equal to 1 to n partial derivative of r mu vector with respect to qi delta qi. This is number 2. Let f mu vector be the impulse acting on the particle of mass m mu. Impulse means external force acting on the particle of mass m mu at any time t. Then sum of the virtual moments of the dynamical system due to impulse is here sigma mu f mu vector dot virtual displacement vector. This is the moment of a force. Here in place of delta r mu, here using 2 we write here, we take next step sigma I equal to 1 to n outside and remaining terms inside, here delta qi. This is number 3. Here delta qi be the generalized virtual displacement. This is the displacement. So, but total term is moment for the impulse. We know that moment of a force is equal to force multiplied displacement. This is the displacement. So, this remains the term moment. So, total virtual moments of the impulse on the system may be supposed to be distributed as the sum of the virtual moments of the quantities, these quantities. We write here due to displacement delta qi I equal to 1 2 dot 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 n. Delta qi be the generalized virtual displacement. Therefore, this remaining quantity, the quantity sigma mu f mu vector dot partial derivative of r mu vector with respect to qi is called generalized component of impulse of the system. It is generally denoted by qi. Therefore, qi equal to sigma mu f mu vector dot partial derivative of r mu vector with respect to qi. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and subscribe my YouTube channel. Thank you.